Welcome to this Advanced Intelligent Resilient Framework, or IRF video. This video is part of a series of videos discussing advanced IRF and are available on the HPE website. Now, the HPE Network Simulator, also known as Simware, is available for download for free from the HPE website. So navigating to the HPE website, we can see that COMWare 7 is a network operating system that runs on HPE high-end network devices. Simware, or the HPE Network Simulator as it's now known, is an ideal COMWare version 7 learning tool which allows users to create, configure, and connect simulated networks. Included in the software is a user guide. So firstly, if I click on the download link, I can select my operating system. So for example, Windows 7 64-bit, or Windows 8 64-bit, or Ubuntu as an example. I'd simply select the version that I want and then click download to download the software. While that's downloading, on the HPE website there's also a link to Brainshark training, which provides a lot of detail on how to install, configure, and use the HPE Network Simulator. So as an example, there's an overview video. There are videos discussing how to create and define devices. There are videos showing you how to install and launch the HPE Network Simulator, and so forth. This Brainshark training video about the HPE Network Simulator is about 55 minutes in length, and I will therefore not try and repeat everything in that video here. I'm going to talk specifically about how to set up the environment for the IRF videos. We are once again using the same Simware or Network Simulator topology throughout this IRF series of videos, so that you can set up and practice what we're configuring in these IRF videos. There's also additional information on HPE's website, including lab guides and discussion boards. So on the lab guide link, there are some labs including basic management as an example and subnet-based and MAC-based VLANs. These provide details on how to configure the HPE Network Simulator for various scenarios. So once again, you could configure a lab for IP subnet and MAC-based VLANs. There's also a lot of information on the discussion boards. So as an example here, you can see that Dimitri asked whether provision switches are supported or ProCurve switches, and Eric has answered that no simulator exists at the moment for provision or ProCurve switches. So it only exists for COMWare. But once again, there's a lot of information available on the HPE website, including training material, lab guides, and message boards. Now, once the software has downloaded, you can extract the RAR file. And then I'll navigate to the files. And as an example, there is a user guide which provides quite a bit of detail with regards to the HPE Network Simulator. It tells you as an example which simulator cards and devices are supported. It shows you the requirements for installing the HPE Network Simulator. So as an example, you need a specific CPU, 4 GB RAM, Windows 7 or later. You need Windows administrator rights. It shows you as an example that you need to configure an environment variable in Control Panel. So you would go to Start, Control Panel, System and Security, System, Advanced System Settings, Environment Variables, and you need to configure your VBox install path. I'll show you some of this as we go through the demonstration. But remember once again that there's good information available in the user guide that you get when you download the HPE Network Simulator. There's even an IRF lab available as part of the file that you download from the HPE website. Now please note, this is not the IRF configuration that we're using in these set of videos. The IRF lab that you get as part of the HPE Network Simulator download is a topology that looks as follows. This is different once again to what we're doing in this set of Brainshark videos, but if you wanted to try other IRF setups, that's available as part of the download. So to install the HPE Network Simulator, I'll double click on the executable. I'm told that I need to download VirtualBox. So be aware please that VirtualBox is a requirement for the HPE Network Simulator. Now in my example, I already have VirtualBox installed. In the user guide, it tells us that if we get a message stating that VirtualBox is not installed, it may be because we haven't configured the environment variable. If we've already done that, we can ignore this message and continue the installation. So the environment variable that we need to configure is in Control Panel. We have to go to System and Security. We need to go to Advanced System Settings. And under the Advanced System Settings, we need to choose Environment Variables. And we need to make sure that the VBox install path is set to the directory where we have VirtualBox installed. Once again, that's all detailed in the user guide, which you get as part of the download of the HPE Network Simulator. So now let's look at how to set up the HPE Network Simulator for our specific topology. Once again, the first requirement for the HPE Network Simulator is to have the Oracle VirtualBox software installed on your PC. We can download the latest version from the VirtualBox website, so from www.virtualbox.org, navigate to the Downloads section, and then download the latest release. Something to be aware of is that you may need to enable the virtualization extensions in the BIOS of your computer. This may require a reboot if the settings are not active yet. So VirtualBox once again requires virtualization extensions to be set in the BIOS of your computer. In this example, we're running VirtualBox and the simulations for our videos in Windows 8. So one of the first things we need to do is make sure that the VirtualBox variable has been set on the system. So on the Windows system, we can right-click and look at the system properties. Under the Advanced System Properties, you will find the Environment Variables, and this is where you need to set the VBox install path variable and point it to the installation folder of the Oracle VirtualBox installation. By default, this points to C Programs Oracle VirtualBox. This is the variable that's being checked by the HPE Network Simulator to ensure that it can start VirtualBox. Once VirtualBox is installed and configured, you need to download the HPE Network Simulator from hp.com as I've shown you. And once that's completed, you can start the HPE Network Simulator by, for instance, double-clicking the icon on the desktop. The HPE Network Simulator, or Simware, gives you a graphical user interface to modify the configuration files and set up topologies. In these labs, we'll use a pre-configured topology, which you can find on the Attachments tab of this Brainshark video. The HPE Network Simulator will pass the text configuration file, and it will then dynamically create the virtual machines on the Oracle VirtualBox program. So when you start VirtualBox, in this example, you can see two systems that have been previously created. These wouldn't be there by default on a new installation of the HPE Network Simulator. We can now open the prepared topology, which you can once again find on the Attachments tab of this Brainshark. This is the topology that we're going to use for this series of videos discussing both basic and advanced IRF. So as I showed you earlier in the presentation, this topology has 4 core IRF units that form an IRF system. So we have unit 1, 2, 3, and 4. There are also 2 access switches as well as a MAD BFD device, in addition to the 4-unit IRF system. Once you've defined the devices in the HPE Network Simulator, you need to make the connections between the devices. In this example, we're making 10 gigabit connections between the core IRF devices. And to keep things simple, we are connecting the last port on one device to the second last port on the neighbor device. And that's how the ring topology will be created in the core IRF system. There's a direct connection between device 1 and device 2 in the core IRF system. Each core device also has a connection to the MAD BFD device, which is an external switch, which could be used for MAD BFD or MAD LECP. The 2 access switches are also directly connected and have in addition a BFD connection between them. And lastly, we have 4 connections from the access switches to the core IRF system. So to set this up, in the HPE Network Simulator, we simply copy the configuration and then paste it into the HPE Network Simulator. In the HPE Network Simulator, we can click on File and save this project, and in this example, we'll call it IRF Advanced. We can now use the Run option, which is available on the toolbar in the HPE Network Simulator. The Run option creates the virtual machines in VirtualBox, so this takes a bit of time. So while it's busy doing that, let's have a look in VirtualBox. As you can see here, it's created a new group in the Oracle VirtualBox Manager, and the group contains all the devices which have been created by the HPE Network Simulator. All the devices are powered off by default, and if we look at the properties of one of the devices by using right-click and then selecting Settings on the pop-up menu, we can see that under Network Configuration that multiple network adapters have been added to the device. For all of the adapters which have been connected to the remote devices, VirtualBox is automatically configured by the HPE Network Simulator to use a UDP tunnel to the remote device. This is how the logical connection between switches is simulated through VirtualBox. There's no need for you to make any modifications of these settings because by default, the HPE Network Simulator is configuring the connections for you. In addition to the network interfaces, we also have serial ports. The first serial port is an internal serial port, which cannot be used by us. However, the second serial port is actually connected to the auxiliary port of the simulated network device. That means that we could use Putty or another application to connect remotely to this named pipe path and get access to the auxiliary port of the simulated network switch. This is once again very useful because you can connect using a terminal client application such as Putty directly to the auxiliary port of the simulated switch. We've received a success message from the HPE Network Simulator, but we're also given a warning about having sufficient memory on our computer to run all the simulated devices. You need to be careful because each of the simulated network devices in this example is using 768 mega RAM. So if you'd like 6 or 7 different devices in the topology to run at the same time, you're going to be using a lot of memory. So for example, around 5 gig to start these devices all at the same time. We can now minimize the HPE Network Simulator and work through the VirtualBox interface. We can now start up one of the devices. So as an example, on device 1, right-click and then click Start on the menu to start the device. It's also possible to right-click on the group and click Start. That will start all the devices in the group rather than just an individual device. In this example, we'll only start up a single device, device 1. So we can see the device is booting, kernel is being booted, and just like every physical COMware device, the HPE simulator devices are factory reset by default and will try to start an automatic configuration sequence. You can stop that by pressing Ctrl-D. The automatic configuration setup enables interfaces and then tries to get an IP address and then tries to download a configuration file. Since in this example no interface is connected to a DHCP server or TFTP server, this process will continuously fail, so we'll use Ctrl-D to break the automatic configuration sequence. Be aware that when you click in the VirtualBox window, your mouse is grabbed by the virtual machine, so there's no mouse pointer available. Ctrl-D breaks the automatic configuration, and pressing Enter or the return key allows us to access the device. Since both the keyboard and the mouse are now captured by this virtual machine, the way to escape that is to press the right Control key on your keyboard. That's the default key sequence to release the keyboard and mouse. When you press the right Control key on your keyboard, the mouse pointer is available once again. This interface acts as the console of the virtual switch running in Simware. There is a disadvantage, however, of using this direct console interface. You cannot, as an example, copy and paste into this console or copy from this console into another console of a device running within Simware. That's why it's preferable to use Putty or another terminal emulation program to connect to the auxiliary port of the Simware device, because then you have all the functionality of copy and paste and other tools available through Putty. We can use the display interface brief command to show interfaces on the HP simulator device. In this example, we have a management Ethernet interface, which is available for out-of-band management. We also have 3 gigabit interfaces, as well as 4 10 gigabit interfaces. So the last port, once again, on the switch is 10 gigabit 108. Be aware that all switch ports, which are shown under the bridge mode output, are administratively down by default. This is different to what you'd typically find on a real physical switch. Let's start the second device. Once the device is booted, we can click in the window and then press Ctrl-D to break the automatic configuration sequence. We can see once again that all interfaces are administratively down on this switch. We know from the HP Network Simulator configuration file that the last 10 gigabit interface 108 on switch 1 is connected to the second last interface 10 gigabit 107 on the second switch. So on the first device, we can use System View and then sysname to change the name of the device to Core IRF1. We can then go on to the interface, so interface 10 gigabit 107, or rather 108, and then we can use the undo shutdown command to enable the interface. We could do something similar on the second device. So System View, sysname Core IRF2, go onto the interface, in this case 10 gigabit 107, undo shutdown, and as soon as we've done that, we get messages on both sides stating that the interfaces have come up. We can use LLDP to check connectivity between neighbors by using the display LLDP neighbor information list command. However, we can see that LLDP is not enabled by default on Simware devices. So we need to execute the LLDP global enable command on both units, which will start the LLDP process. And once we've done that, we'll be able to see LLDP neighbors in the list. So in the output of the display LLDP command, we can see that we have a neighbor device or peer device with a system name of Core IRF2. Our local interface used to connect to that device is 10 gigabit 108, and the Core IRF2 device is using interface 10 gigabit 107 to connect to the local switch IRF1. So we've now seen how to boot the devices and connect to them via the console. We can use the display line command to view consoles, auxiliary ports, and VTY lines on the switch. The display line command is the new version of the display user interface command that was used in COMWare 5. The console port is once again the simulated interface to the console of the virtual machine. So up to this point, we've been configuring and accessing the devices directly through the console. But that has the disadvantage once again that we cannot copy and paste between consoles. The auxiliary port is once again the second serial interface on the virtual machine. So if we go to settings and look at the serial ports, we can see that under port number 2, there's a pipe that we could connect to remotely. So in this example, the auxiliary port is mapped to the named pipe // dot // pipe / and the name of the device in VirtualBox, in this case IRF ADV-device1. So in this example, it's based on the topology and then the device ID. So this information is useful once again because we can use Putty to connect directly to the device through the auxiliary port and make use of features such as copy and paste. It also means that we don't have our mouse being captured by VirtualBox and having to use the right control key to escape the VirtualBox. So there are multiple advantages to using the auxiliary port rather than the console port for configuring the virtual machines. So looking at the Putty configuration, we're going to be using a serial connection, but rather than using the default COM port, in this case COM1, we'll connect to //dot/pipe/name of topology and the device, which in this case is device 1. This information can then be saved as a session. In this example, it was already saved as core IRF unit 1. So we can now open this connection. Don't forget that in Putty, under the keyboard settings, you should set Control H as the backspace key to use the backspace on the keyboard rather than Control H to remove characters. So now when we open this connection, we now have a normal Putty connection to switch 1, and we can do something similar for switch 2. So we can start the second session. In this case, the session was saved for device 2. So when we open that, we can connect to the console of device 2 using Putty as well. In this case, we connected through the auxiliary port of the switch rather than the console. We can also see on the console that a user has connected through the auxiliary port. When we use the display current configuration and look at the line block, we can see that the console port has the default user role of network admin, which gives you read and write access to the device. However, by default, the auxiliary port only has a user role of network operator. This means that when you connect via the auxiliary port, you only have a read access to the device. So when we try to access the device using the Putty connection, and we enter System View, and we look at the list of available commands by using question mark, we can see that only a very limited number of commands are available. This means that we've connected as a network operator with read-only privileges. So we'll close the Putty connection. So what we need to do is make sure that we assign more privileges to the auxiliary ports. This has to be done initially through the console port. So via the console connection to the switch, we can go to the auxiliary port, and under this context, we can assign a user role of network admin. Once this is configured, we can open our Putty connection again to Unit 1. And when we log in, we'll need to log out and then log back in again. And we can now see that in System View, we have all the configuration commands. This means that we can now minimize the VirtualBox console and do the configurations via the auxiliary port using Putty. One disadvantage or drawback of using the auxiliary port is that we only configured auxiliary port 0. We would firstly need to do something similar on the second unit or second device. In this case, we would also configure the auxiliary port 0 with user role network admin. Now this will work at the moment because these two systems are standalone devices, but when they join an IRF system, we'll end up with two auxiliary ports, auxiliary port 0 and auxiliary port 1. Hence, auxiliary port 1 will not have network admin privileges. So to demonstrate the problem, let's save the configuration by using the save safely force command. And now we'll change the IRF member from member 1 to member 2 and then reboot the system. After we reboot the system, the auxiliary port number will change from auxiliary port 0 to auxiliary port 1. So at the moment, the display line command shows us that we have an auxiliary port with a number of 0. So let's see what happens when we reboot the system. We'll reboot using the force option. In other words, reboot without being asked to save the configuration. Note that we don't have to save the IRF member ID configuration because that's being saved in the NVRAM of the switch. The system is now being rebooted. In the background, we can see that the virtual machine is being reloaded. Once the virtual machine has reloaded, we can access the auxiliary port again. But as you'll see here, when we enter System View, we only have a limited number of commands again. When we access the console and use the display line command, we can see that the auxiliary port number has changed from auxiliary 0 to auxiliary 1. So both the console and auxiliary port have been changed to 1, which are the numbers used by IRF member 2. So the configuration settings that were made on auxiliary port 0 were lost when we renumbered the IRF device and rebooted it. There's a very simple workaround for this issue, and that's simply applying the configuration to a class rather than directly to the line. But before we do that, we'll renumber the IRF member back to member 1 so that we can demonstrate that the new configuration will be effective after a renumber of the IRF member. So the system has been renumbered back to Unit 1. So using the display IRF command, we can see that we have member ID 1. And with the display line command, we can verify that we have an auxiliary port with number 0 again. And by using the display current configuration line, we can see that line auxiliary 0 still has network admin privileges. So in order to apply the configuration to future auxiliary ports, we will enter System View, and then instead of applying the configuration to the line auxiliary port, we'll now apply the configuration to the line class auxiliary port. So this class will be used as the default for any future auxiliary ports that may be added to the system. So in this case, we'll set the authentication mode to none, and we'll also configure the user role to network admin. We can review the configuration by using the display this command. So the line class auxiliary now has the authentication mode set to none, and the user role is set to network admin. So let's save the configuration. We'll now once again renumber the IRF device. So IRF member 1, renumber 2. We can then reboot the unit. And we should see that after the reboot, that the connection to the auxiliary port still has access to all commands. We can use the display line command to see the auxiliary ports in the system. And in this example, we are now connected to auxiliary port 1. But unlike previously, we still have full access to the system. So this is a very useful technique to remember, which also applies to real IRF systems. So whenever you prepare the first IRF device, make sure that you apply the console settings to the line class auxiliary port. These settings will be effective for any future IRF members which are added later on to the IRF system. This is also critical to know when you want to set up an IRF system using the 6125XLG, which is the blade switch available for the C7000 chassis. Because this switch has an internal console connection, which is connected to the onboard administrator, and you also have an auxiliary port, you need to make sure that you prepare the line class before you renumber the IRF member ID on these devices. That concludes this video explaining and demonstrating the setup of HP Simulator or Simware in preparation for the IRF videos in this series. That concludes this video discussing advanced IRF. This video is only one of a series of videos discussing advanced IRF configurations. Please look on the HP website for additional videos to help you configure and troubleshoot HP IRF. Thank you for watching.